Now, as I recall, I've already asked this question earlier this semester. I think when we were studying differentials. So let's look at it completely differently. Let's use Newton's method. Let's use Newton's method of approximation to approximate this beast. To get me started, let me take that darn mathematical beast and give it a name, just to clean things up and look nicer. Does that imply this? And does that imply this? Newton's method involves setting the output of some function f of x equal to 0 and a half. So if you don't mind, and pay the consequence of our actions. And so would you not agree that the n plus first approximation is just a previous approximation minus the ratio of the function f evaluated at the previous approximation to its derivative evaluated there? That's what this recursive description says. Now, that being the case, I mentioned the ANS command on my calculator, but what I'm really doing is typing this in. Well, excuse me, I take it back. I type in an approximation first, my initial guess. Clearly, 36 is what I'm going to use. So when I plug 36 in for x, I said 36. Sorry, don't I really mean 6? So I put 6 in my calculus screen, hit enter. Then I'm going to type this expression in, but every time I see an x event, I'm going to use the ANS command. So I type in 6. And now I got my answer minus a fraction, so open parentheses. Answer squared minus 38, close parentheses, that numerator. Divide by the number is complicated, so open parentheses. And that's going to be 2 times previous answer, close parentheses. I'm coming up with this. Okay, I'm old. I don't know how many 6 here. I think it was about 7. However, there's a second iteration of Newton's method approximation, or several iterations. I'm coming up with question mark, which is around 8 or 10, to be this. Now let's see how close that is to the square root of 38. My calculator says the square root of 38. Let's see. Can't see anything. Oh, look at that. It doesn't deviate from this at all. It agrees all the way down to there. Impressive, quick conversions to the actual root, or at least an approximation thereof.